Okay, so hi there. Today I'm going to speak about maintainable code. About maintenance, but not precisely about maintainable code. About how to write maintainable code and what is maintenance. But before I start, let me introduce myself. My name is David Hernández. I'm a Drupal developer from Valencia. I've been working with Drupal for almost 3 years and a half with IO1. Yeah, so at the moment I'm working as the development manager. With that role, I'm in charge of the quality of the code and with the process of improvement, the processes of working and technologies. So, since I started, I noticed that the maintenance is really, really important, and more when you work with more people. So, why it is important to write maintainable code? For example, we usually, with the websites, we take a lot of care with the design. So we spend a lot of time working on the design that looks beautiful, looks pretty, it looks interesting. We also, like this building, for example, maybe it's well designed, but it probably has more problems. So, for example, it happens the same with the museums. The museums are, for example, are really accessible and really usable. They have a really clear objective that is showing the pieces of art. Doesn't have anything in the middle that can stop you to seeing the pictures. It has ramps and usually big doors for the disabled people. So it has a real clear objective, and it's really well designed and built for that. But the problem is, what happens with the foundations? That's what usually happens. And that's also what happens with code. When we write code, the code is the foundation. The code is the foundation of our product. Is what we develop and what we do is just building above the code, with the code. The code is the base. If we don't take care of the base, of the foundations, we will have problems. It's not only how looks or how fast is our code, like a car. The problem is, if we have a problem, how much time it will take to us to fix it and to be on the road again. So what can we do for that, to fix that problems, that issues? There are several things we can do. One thing, for example, is the names. This is, for example, a card. You say ID, role, works for, mail. That might work because this case is really, really simple. But what happens when we add more and more text? These names that can look correct now, with a longer text or a longer code, might look confusing or might cause problems of duplications. For example, ID, even if for a name might work, if we have nodes, we have users, we have ID is not enough. So we have to improve that. Here is a better example. So we have a name, job role instead of work for, company, email, because mail can be used for something else. So that can be applied to everything on the code. Everything on the code has names. The variables, objects, functions, everything is a name. And if we do good names, we will have done almost the half part of the job. The next step we can do is, for example, simplify the functions. Here we have a traffic light, no? But it's doing too much things. It will work, maybe, but it's really difficult to find if any of these ones is failing. It's really, really difficult. For that, we have to follow some patterns, some techniques. For example, the single responsibility principle. That's a function does one thing and only one thing. An object has an objective and it has a clear objective and does only one thing. So if a function is doing two things, just split it in two functions. It doesn't cause any problem. It's not going to affect anything else. So, for example, a condition in a function is one thing. It's taking a decision. Then we will have one function for one condition. Then the rest, we will extract it in different functions. We will gain a lot with that. Because if we use good names and functions, little functions that does only one thing, the code will look just like normal text. We will just read the text, and we will understand what it's doing. For example, this man here is trying to do a lot of things by himself. And probably he's good, and he's doing well. But it has more chances to have an error or a problem. But if we split that in a band, it will look more awesome. It will be way better because everybody is completely focused in just one thing, and it's more easy to look what is the problem or where is the error. Another thing we should do with the functions is don't repeat yourself. Even if we have a line that you say, okay, it's only a line. If I change it for a function, it's not that important change. But if we have that line in several different parts of the code, why don't we extract it into a function? Just put it in a different function, and you will gain more readability. It will be more easy to read. Also, keep it simple, everything. Keep it simple, stupid. If you do your code as simple as possible, everybody will be able to understand it. It will be really easy because at the end, you don't read code, you read a text. Because if a function has a good name that is chained with a good variable names, you will read it. It's really easy to read. So if we have better names and simpler functions, we will have also happier developers and people maintaining that code. When I'm saying maintaining, I'm not talking only about people who work in teams. Maintenance, some people consider maintenance that the second line of code, because you are already working with other code. Even if you work only alone, you will have problems, because if your code doesn't have a good structure and doesn't take care of how you are writing the code, when you see the code again 2 months later, you will think, okay, what the fuck, who done that? Then you see the logs, and you say, okay, it was me. So what the hell I was doing? So maintenance is not only for big teams. It's about working for yourself, working in teams, working with the community. And we have to take a lot of care and be careful with how we do it. Other part, if we have a lot of indications, you say, okay, indications are good because it helps us to find our way. The problem is if we have a lot, at the end, it's really confusing. You can think one indication is easy, but when you have 100, it's really difficult to find your way. So indications are not always good. And what I'm talking about now is about comments. You think that comments are good because it explains what it's doing. But comments have also some problems. For example, if there is a comment in a function, it means probably that the function can be simplified. Some parts can be extracted, sometimes can be changed, and the comment at the end is useless because you don't have to read the comment to understand what it's doing. Also, it happens if you put a comment above a variable or a function, because it means that the name is wrong. The name can be improved. Also, another big problem with the comments is that the code evolves, but the comments don't. So, if you are writing a function, and you say, okay, that's really complex, what I'm going to do is add in a comment explaining what it's doing. Then you put your comment, explain what it's doing and how it is doing it, but then someone else goes and says, okay, this piece of code is a piece of shit. I'm going to rewrite it, and then change the code and fix it, and looks easier, readable, and way better. The problem is, he probably will not change the comment. So the comment is there, but doesn't make sense anymore. So please, don't do that. If the comment is wrong, then remove it. If you don't need that comment, then don't put it. I'm not saying that comments are bad, but usually, when you have a comment, it means something. If there are a lot of comments, it means that something smells, and something smells really bad. So please take care of what you are doing. There are some times that a comment is really necessary, because the code is really complex and not always can be simplified. But please reduce it. Reduce that code as much as possible. Also, sometimes you are forced to write comments. For example, Drupal says that we have to write a comment about a hook saying implements, hook, blah, blah, blah. So that's necessary, that's okay, that's fine, because we are following a standard. But it doesn't mean that we have to use it always. So what I say is more or less the biggest part. The problem is the devil is in the details. The little details doesn't have a right solution. There is no clear solution for that. So we have to take care of the little details, and just, I'm not going to say you how to fix that, because there is no real solution. For example, I'm going to show you some examples. Here, camel case versus Hungarian notation, tabs versus space, Windows versus Linux versus OS X, panels versus context. There are a lot of eternal discussions that there is no solution. So you can try it, but always will be someone who thinks different to you. So what you should do when that happens? Use the standards. Use the Drupal standard for code. It's really good. The problem is the Drupal standard doesn't cover all the possibilities. So in that case, do an agreement with your team. But people always have different opinions, and there is people who doesn't want to change his mind or doesn't want to use something else. So when that happens, you have to take a decision. It's better to take a decision than just waiting forever till the discussion's finished, because it will never finish. Never. Some last advices. Refactor. Refactor means upgrade your code, change it again, rewrite it. It's not always, okay, this is bad, I have to rewrite it. It's not only that. For example, if you spend, to get better at writing maintainable code, you have to write a lot of code. But not only new code, you have to maintain the code, change it. Even if you think it's good, it always can be improved. So if you write alone, or if you write, for example, with an issue system, then if you have to spend just 1/5 of the part of time you have used on that issue to refactor a bit. If you work with pair programming, then before writing the test for your mate, just refactor a bit before. And that will help us a lot. If you work with Pomodoros, then put a Pomodoro of refactoring or something like that. The code, it will not get worse. It will get better and better. So there is a simple rule for that. And it's a really easy rule that has been taught to the kids for a long time. It's the Boy Scout rule. Always leave the campground better than you find it. If you see that something can be improved or something is wrong, just change it. Don't wait, because probably will stay there forever. So even if you wrote that code, if you see a function, probably later it will not make that much sense. So update it. It's not a problem. It will just get better. It will not be the best from the first time. Testing. You think testing is really good because help us to get a more stable environment. If we change something, it will be easier to notice when something breaks. But testing is not only that. It's not only good for that. If we have a good coverage of testing, if you want to see how something works, just look for the test that does it. Then you go there, and you can dig in the code. First, you see that it's working, because the test says if it's working or not, then dig on the code to see how it works. Then you can go through the functions. One good thing of writing little functions that are really simple is that when you read the function, if it's working, you don't have to dig to see how are the details working. You don't need it. So the same is applied for testing. Once you see it, if you have a problem, then you can dig until you find it. But if not, why spending 1 hour reading 200 lines of code if you can read it in just 4? Version control. Well, before version control, if you are interested on testing, tomorrow there is a workshop starting at 12 about TDD and BDD with Symfony 2 with Carles. So it will be really interesting. Version control. I'm not going to say that it's necessary. If you don't use version control, you are doing something wrong. It's the most useless tool we have, not only because it helps to track everything, but, for example, it's really common to find lines of code commented that stay there forever, because you say, OK, I will comment it because maybe later I will use it. Then you leave it there. Someone arrives, OK, I'm not going to remove it because I'm not sure if that will be used later. Then happens, and then you have a module with more commented code that actual code. So you can throw that away and start from the beginning because it's a mess. So for that, we have version control. If we have to go back, then revert. It's free, just like doing a commit. So use it. for what I have explained, there are several tools that help us with that. A lot of tools. For example, one is Code Sniffer. With Drupal, we are really lucky because we have a module called Coder that checks our code and tell us what is wrong with our the standards. The problem is, for that, you have to tell the developer to check it, to use Coder. And they will do it sometimes, but not always. So Code Sniffer is a tool that allows you to filter the code, and it can be connected, for example, to Git or SVN. Drupal has already a module called Drupal Code Sniffer, Drupal CS, that is really helpful. And it's just a library you can install, and with a bit of time, you can connect it to your Git. The problem is you have to study where you want to use it, on which hook, on pre-commit, pre-push, or something like that. But once you have decided, it's a really good tool. Continuous integration. I'm not going to talk about continuous integration because tomorrow there is a session about Drupal and continuous integration at 11 in the same room. So I think it's one really interesting if you are not into that. Sonar. Sonar is a tool of evaluation that evaluates the source code and gives you some metrics. It's really helpful because it tells you that, for example, the 40% of your code has comments or are comments. It tells you the coverage of the testing. It tells about cyclomatic complexity. It tells you a lot. The problem is there is no rule that it's absolute. There are always exceptions. So don't use the metrics that gives you Sonar as a rule. Use them as a guide. It's also, for example, Sonar can be connected to the subversion, so it can give you, every time you do a commit, a push, or Git, well, whatever, it will give you a report. You can check the report. You can connect it to some other tools. For example, if you have an integration system, you can write some plugins to connect it and to have reports of the code. I'm not going to suggest you that you run Sonar on Drupal, on the Drupal core, because you will be scared. It will say that it's probably the worst piece of code you have ever seen. I'm not saying that Drupal is bad. I'm saying that it can be improved. Always, the code can be improved. So, as a quick overview, you can summarize all this session in 3 simple ideas that applies everywhere. Simple, readable, and common for all the team. Doesn't make any sense if you have a really strong rule, but only apply it yourself. Your team has to do it too. So keep it simple, keep it readable, and that all the teams should do the same. If not, you are wasting your time. Any questions? Yeah, I know, it's really quick. Questions? Yep.
I have a question about keep it simple and keep it stupid. Because generally
Not keep it simple and keep it stupid. keep it simple so a stupid can understand it.
But the job said keep it stupid.
Yeah, okay, it's...
Whatever.
No, they add the stupid because then you can use the keys. It's for example, don't repeat yourself is DRI. I will show you.
My question is.
Yep. Yep. What is? Say.
Yeah, actually, simple things is always make duplicated a lot of kind of like the similar stuff.
Mm-hmm.
So it means the code will be very long and very difficult to manage the code base code. Actually, how to I don't know. PHP is kind of objective programming, but actually it's not that powerful like Java. How to make it better to keep it simple?
Okay. Yeah. Yes, that rules are easier to apply to, for example, Java or more object-oriented languages. But I tried to put a quick overview of what is maintainable code. Yes, it's true that it's not always can be improved because procedural programming, it can be hard because you don't have a lot of tools that helps you with that, like objects and all of that. So just try to keep it as simple as possible. If you are working with an object-oriented language, I will tell you that you should probably a function should not be longer than 10 lines of code. With PHP, probably you can go to 20 or a bit more. Depends, always depends. So there are no rules. So just try to be flexible as possible, and keep it as simple as possible. Any other question? Nope? Okay, I want to show you, well, as a recommendation, well, here is, keep it simple, stupid. They add the stupid, so they have a second S for put it as keys. So keys, and don't repeat yourself, it's dry.
One of the tools I find very important is to have code reviews between the team, because it helps to make a culture of good code in the team.
Yep. Communication is really important in a team. It's usually good to do a code review from time to time with the team, because what you don't see, probably someone else will see it. So try to take some time to do it. It's hard. For example, in my company, we usually work in a remote environment. There is not an office with more than 3 people, I think. So, and probably they are working on different projects. So it's really hard to do it, but you can try it. So, for example, we don't do live code reviews, but some people receive an email with every commit, so you can check it. And it's not a good idea to go to a developer and say, okay, this is a piece of shit, please rewrite it. So you have to, there is a lot of psychology, of group psychology, we were discussing that the other day. Yeah, you have to be diplomatic. So instead of saying, this is a piece of shit, please rewrite it, you say, okay, I think this piece of code can be rewrote. Who can imagine a solution? So try to make it a part, so all the team works in trying to fix it. And you're not going to see who did it, but he will see it and say, okay, that was me. So he will always learn, and you are not pointing to someone.
And one of the other advice I would give is to have a limit about the number of to-dos you can write.
Mm-hmm.
Because we all are...
Yeah, all of us put to do on, but...
When you have more than 10 to-dos, okay, I'm not going to do it. So
yeah, we don't allow to-dos on our code. If we see a to-do, then do it. Oh, then don't put the to-do. So I don't know that there is, but you will have to fix it later, please. So as a recommendation, I recommend clean code. Clean code is the Bible about maintainable code. There are other books, but if you haven't read it and you haven't been into that, this will change your mind about how to write code. Yep.
When will you say it is okay to write a comment into a function? Because you say the best is to not write any comments or
the less comments as possible. Yeah.
I think sometimes it's necessary to write some comments.
Can you put an example of one?
I don't know. Maybe if you use a complex math function to solve a problem and you cannot split that function in a simple one.
If you are, for example, trying to do a calculation, a complex calculation, you can write a function that the names of the function does that. So you don't need to explain that, because you will not put the code directly inside another function. It will be a function that you say, this function is doing that. So you just read the function and tells you what it's doing. So you don't need a comment to explain that.
I think it's a good case because sometimes it can be more readable if you can express the math formula and not the programmatic one. I agree with him. This is one of the few...
Yeah, there are a few cases where it's better to write a comment. For example, in really complex algorithms or sorting algorithms, usually it's hard to make it simpler. So sometimes it's correct, it's okay, but shouldn't be the rule, the culture of the company to write comments. Yep.
Like to add a point there. Sometimes when I'm writing code, I think, what would somebody who's gonna read my code think, or how can I make it easier for other people to read it? So writing displaying comments is not bad. It's bad to overwrite comments. So if you ever, as David said, if you have a function that is well defined with a well dot plot on top of it, then that's fine. But just see it this way: it's easier to read text rather than reading loops. It's gonna be, less brain consuming. So just try to put yourself in others' shoes and see whenever you need to put a comment or not. It's gonna really save time to others. And even to you, after a few months, you will discover that you did something wrong. If you read the comments, it's gonna be even easier for you as well.
There is a sentence that talks about that. If you apply that, you will save a lot of problems. It says you have to write code like the person who will maintain it is a crazy man with a chainsaw that knows where you live. So if you know that, you have to take a lot of care to just write it as best as possible.
And maybe if you think there is a comment needed in a function, then this comment has to say what it does, not how. Because how
or why.
can change, any other programmer can change how the function does something, but what it does is quite difficult to change.
Any other? Yep.
Would you recommend any kind of tools for like visualization tools, like for instance diagrams for the code?
Sonar is a really good tool, but yeah, Sonar is good. It's it needs to. I can't find a perfect tool for that. There are several tools for checking the code. It depends a lot of the. There are some that are only for some languages. Also, the different languages change. So, I'm not going to recommend you a tool because it will depend a lot.
Because sometimes I think it's useful to have like a diagram with the execution flow.
Yeah.
And I still do it manually with Dia or something like that. So I don't know if there's something that somehow can.
Sonar is a really good tool for metrics and for evaluating the code. Also, it can be, you can put plugins or change, so it can be adapted to your standard, or when it should tell you, okay, there is a warning here. So it's really flexible in that. I think, I'm not sure, I haven't checked Sonar that much, so.
Whenever I want to review a long flow, for example, a full bootstrap, I use xdebug.
But that's something completely different, I think.
Yeah, I mean, that to follow a flow.
Yeah.
Somebody has written or to see what's happening in the background. That's the best way I can find.
Yeah, you can combine it with cache grind, which represents the xdebug info to you by a
Yeah, cache grind is, have you tried? Yeah, it takes the file that generates xdebug and processes it and generates graphics about what functions are being called, what is taking more time, but that, I think, that's completely different topic. More questions? Okay, if you have liked the presentation, you can download it from my website or from the DrupalCamp website. I haven't uploaded it yet, so don't be that quick. I know that the presentations have a lot of images, so I put on the code, on the HTML code, comments with what I've been saying, so you can follow it if you want. So thank you so much. I hope you have enjoyed.